Hi, this is today's lesson about further maths and about how you can get the most out of notes. So it's really important that when you're going through these further maths notes that you listen to the presentation, that you make notes of it. If you get stuck, replay it and remember to practice as you go through it. Now here's for today's. These are the notes that relate to exercise 3A, which looks at measures of centre, 3B, which is looking at spread in data, and looking at exercise 3C, which is looking at the normal distribution in reference to statistics. So if we have a look at the first thing, which is 3A, measures of centre, there are two different ways that we can measure the centre. The first one is we can calculate using the mean, or sometimes referred to as the average. Okay, and the second way is we can calculate the median, which is the middle result out of the data set that you have. It is important to note that if you have data that is skewed, it is a much better measure of spread to use the median to measure the centre rather than the mean. And the reason for this is that the median is less affected by outliers or extreme values in your data set. So if you have data that's skewed, remember that you should be using the median instead of the mean to measure the centre, and that has been a past exam question, a multiple choice one in the past. Okay, so how do we calculate the mean and the median? So this is the same as what you've done in chapter 2, but let's just do a quick recap. So I've got an example here. And what I'm going to do is I'd suggest that you pause this so that you can copy down the data into your graphics calculator. And then once you've done that, press play again and you'll see the following. So if I go into the graphics calculator, I've loaded the data in a new list and spreadsheet sheet. And then what I need to do is calculate the median and the mean, because we're going to do a bit of a comparison, see if they're similar, but also then make some conclusions about that as to which class did better. Did my class A do better overall than class B? And we'll talk about that in terms of the mean and the median. Okay, so how do I do that? I select menu and then I select number 4 for statistics, and then I select number 1 for calculations. Okay, and we're still doing one variable statistics, so you select number 1. Now, we have two lists here, Class A and Class B. Now, there's two ways that you could do this. You could do the calculations for Class A and then do the calculations for Class B, or you can actually get the calculator to do both at the same time. And the way that you do that is you change number of lists, instead of being 1, change it to be 2, and then select OK. Alright, once you get to this screen here, you need to do the same as before. So I would like Class A's results in the first one, and I would like Class B's as my second set of results. And once you then either tab across or click OK, you'll see that this will come up. So the first one that we're having a look at, and I'm just going to move it across so that you can see which one it is. If you're not sure which results are in which list, if you click on the grade box here, can you see down the bottom that it tells you that it's Class A? And obviously if I go across to the next one, it tells me down the bottom here that it's Class B. So that's a quick way to check which data you're actually analysing. So if we scroll down, obviously we can see here is our mean for Class A, and here is our mean for Class B. So obviously on average, the students in Class B did slightly better than Class A because the mean was higher. So if I then scroll down, we're now looking at our median. So the median for Class A was 33.5, and the median, so the middle result for Class B, was 36. So again, we can see both the mean and the median show that Class B actually was performing better than Class A. So when you're answering these things, you'll see from past exam questions when I set them later as homework that it's important, A, to be able to calculate the mean and the median, but what's more important, and that's what distinguishes between a good mark and a very good mark in further maths, is you must be able to then interpret what those results mean. So doing a comparison is really important. Okay, so that covers measures of centre. So it's still recapping, I guess, really from chapter 1 and chapter 2 as well. The next thing that we have a look at is exercise 3B. So with 3A we've discussed the centre. In 3B we're looking at measures of spread. Okay, so this is recapping as well. So there are several different ways that we can talk about the spread of data. The first one is looking at the interquartile range, which we covered in chapter 2. And you'll need to remember how you actually do that. So it's important to be able to calculate Q1 and Q3, and that the interquartile range is just Q3, take away Q1. The range, okay, has been recapped on before, covered before. Then it's just another measure of spread, which is the biggest value in your data set subtracted from the smallest value. The third one that we look at is called the standard deviation. Okay, and if you have a look here on your graphics calculator, and I'll show you on the calculator in a moment, the symbol is SX when we look at it when we're doing a calculation. It is just another measure of how spread out your results are. So obviously the bigger value for standard deviation means that it's more spread out. Okay, in further maths, we don't have to calculate this manually. We just use our graphics calculator to calculate it. But the important thing from these notes here is that it is only appropriate to calculate the standard deviation if your data is symmetrical. So again, if you have skewed data, you cannot use the standard deviation as a measure of spread. Okay, so let's go back and have a look at our calculator about where the result is. So if I just scroll back up a little bit, can you see this one here, this SX? Okay, that's our measure for standard deviation. Okay, that's the symbol that we use. So obviously class A had a standard deviation of 5.3 compared to class B, which had a standard deviation of 4.98. So class B's results were not as varied as class A if we talk about it in terms of the standard deviation. So that's another measure again. Okay, so I've shown very quickly how you can calculate the standard deviation on your graphics calculator. And then what we're going to do is move on to something that you won't have seen before, okay? And it's looking at normal distribution. So that's when our data is symmetrical, okay? It has here that 50% is above the median and 50% is below. It also is the mean and the median are in the center here. So in general terms, what does it look like? I'm just going to change the color. Okay, so this is our normal distribution here. So in your own notes, you're going to have to draw something like this. And my drawing's not fantastic today. Okay, and I'd like you to do, what we're actually going to do is we're going to do 3 of them. The first one we're going to look at is the 68% rule. Okay, which is here. So these other 2 lines that are here will become more clearer in a moment. But what does that mean? If we look at the results here, the first thing I want you to be able to tell me first of all, or to label, is that in the center here is the mean. I'm just going to make that a little bit smaller. Okay, so in the center here is the mean, okay, because our data is symmetrical. If we're looking at this point down here, and I'm not sure why it's gone, maybe it's skewed for a moment, it's the mean plus 1 standard deviation. Okay, so at this point here, if the screen comes back, okay, it doesn't like that. Okay, so we're looking at this point here, and I'm just going to change the color so you can see it easily. So if we're talking about this point here, we calculate it by the mean plus 1 standard deviation. And when we go through some examples in a moment, it will become clearer, but let's just go through the definitions first. And then what we're going to do is this value here, just need to change my pen. Okay, this one here is going to be the mean minus 1 standard deviation. So I'm just going to write that in quickly. Okay, so what does it mean? Well, in between these two red lines that I've drawn in here, 68% of our results can be found. Okay, so all this in here, okay, will have two values, and when we go through the example in a moment it will become really clear, but 68% of our results are between the mean minus 1 standard deviation and the mean plus 1 standard deviation. So obviously if this in the center here is 68%, okay, we have, for it to add up to 100%, we have 32% left over. Okay, and because our data is symmetrical, it means that there is 16% here and 16% here. Okay, so now would be a good time to probably pause the video so you can copy this down or have the notes already printed out for you. So we've got 16% above and 16% below. Now this will become clearer as to why this is important when we have a look at some questions. Okay, so that's our 68% rule. So if we then have a look at, and I'm just going to copy something before we move on. Okay, if we then move on to the 95% rule, okay, we have the same thing in the middle here again. Okay, we have the mean in the center. Okay, but this time we're going out further. Okay, we're going out to this point here, and we're going out to this point here. So this is what we call 2 standard deviations away. Okay, so obviously this higher point here is going to be the mean plus 2 standard deviations. And I'm just going to move it so you can see it. So I'm just going to change it so it says 2. And on the other side, it's going to be the mean minus 2 standard deviations. So I'm just going to copy this again and paste it over here and change it to be minus. Okay, so then we have our 2 boundary points. So the one on the right is plus 2 standard deviations, and the one on the left is the mean minus 2 standard deviations. Okay, I'm just going to change that so then you can see it. So the same thing again, it would be good in a moment to pause this so you can see what it is, but obviously inside here, so from this point all the way up to over here, 95% of our results fit within that range. So what that means is we have 95% in here, so we have 5% left over. And again, because it's symmetrical, we have to take that 5% and halve it. So what it means is that 2.5% of the data is above that point, and 2.5% is below that point as well. Okay, and again, it will become a bit clearer once we go through an example. So at the moment, we're just looking at each of the definitions, so you can have notes written down about it, and then we'll go through an example to make sense of it. Okay, so the last one we look at is the 99.7% rule. So the same thing again. We have the mean in the middle here. Oops. And then what we're looking at is going out to this point here. So I'm just going to highlight it again with that line. So we're going out to almost all the results. Okay, 99.7% of the results fit in between these two values. So obviously the one on the right hand side, if you haven't guessed already, is the mean plus 3 standard deviations, and I'm just going to abbreviate standard deviations to be SD. And obviously this one over here is going to be the mean minus 3 standard deviations. Okay, So what that means is we've got, again, if I'm looking at all the results inside here, 99.7% of the results fit within that range. Okay, and then we have, so 99.7 is here, which means we have 0.3% left over to add up to 100. So on our right hand side, this little bit in here, which is really hard to see, but we have 0.15%. Okay, and obviously it's the same on the other side as well. Okay, so I'm just going to mark it in here. And that didn't work. Okay, I'm just going to scrap that. Okay, so if I do over here, it's the same. It's 0.15%. Okay, so we've covered the definitions of the 68% rule, the 95% rule, and the 99.7% rule. Okay, well, I just finished sketching this. What we need to then have a look at, well, what does it look like in a real life example, or an example that or question that you might get in an end of year exam. So here's lots of questions based on some information about normal distribution. Now, in an exam, you'd be given one of these, usually as a multiple choice question, but we'll go through lots of different ones to make sure that you understand how to do lots of them. So, my first piece of advice is that when you're looking at doing a question that says normal distribution, I would be doing this. Somewhere on your page, and you have to excuse my very rough sketch, but I would be drawing the normal distribution. Okay, I know straight away that the mean is 30, so I'm just going to write in 30. Okay, and I know that the standard deviation is 5, so if I go the mean plus 1 standard deviation, it's going to be 30 plus 5, whoops, plus 5, which equals 35. And I might just write in 35 so you can just see the total. So that's going to sit about here. And obviously then if I go out 2 standard deviations, it's going to be 30 plus 2 times 5, which is 10, which gives us a total of 40. Okay, and then obviously if I go out 3 standard deviations, it's going to give me a total of 45. So that's that 30 plus 3 times 5. Okay, now obviously if I go the same the other way, so I'm not even looking at the questions yet, I'm just drawing in a quick sketch because I know, I'm just going to change the colour, okay, is that if I go out 1 standard deviation I get to 35, if I go out 2 standard deviations I get to 40, and if I go out 3 I get to 45. Now if I do the same on the other side, 30 take away 5 is 25, and then obviously the next one lower than that is going to be 20. I'll just put it down here. I'll just move it up a little bit, and then the last one is going to be 15. So that tells me that, and I'll just write it in first. Okay, that tells me the following, that 68% of my results fall between 25 and 35. 95% of the results fall between 20 and 40, because that's that 95% rule. And 99.7% of the results fall between 15 and 45. So I would be suggesting that you draw a quick sketch like this. And obviously, if you've got a bit more space, you could draw a little bit bigger. But that's the key to it. And then it might be helpful to write things in, and we'll go through it in a moment. So the first one we're looking at, what percentage is between 25 and 35? Well, I can see here it's 1 standard deviation. So I know straight away that that's 68%. Okay, because it's 1 standard deviation. If I'm looking at between 20 and 40, can you see that it's 2 standard deviations? So from our notes that we did before, we know that that's 95%. Okay, and obviously the next one, no surprises, that this one here is our 3 standard deviation, which gives us that 99.7%. Okay, so we've got 3 pretty easy questions so far, okay, to answer. The next ones that we go through do get a little bit harder. So what percentage of the cohort is over 30? Well, 30 is our halfway mark, okay, which means that 50% of our results are above 30 and 50% of our cohort scored a study score lower than 30, okay. So obviously our result in here is 50%. And then if we move on to our next question. So E says, what percentage of the cohort scored above 40? Well, 40 is our second standard deviation, that 95% rule. So what would be a great idea is when you're looking at this as an exam question, you might flick back, and I will quickly. Okay, 2 standard deviations is the 95% rule. And I know that from here, 2.5% have above that score. So to answer the question, 2.5% had a score above 40. Okay. So I also know that if we're talking about, if we look at now E, the maximum score a student could receive and still be in the bottom 2.5%. Well, I know that 40 is in the top 2.5%, and I should know that 20 is in the bottom 2.5%. So the maximum score a person could have received and still be in the bottom 2.5% is a study score of 20. Okay, so, and the last one here is the one, it's similar to a past exam question, and it tricked lots of students. It wasn't that they couldn't work out the normal distribution curve like we've just drawn. What threw them was that they had to work out in relation to the number of students that they had. So let's go through it together. It might be a good idea for you to pause it for a moment and see if you can work out what the result should be before I go through the answer. So if you've paused it and had a go, here's the calculation that you needed to do. You should have been able to work out, and most students did straight away, that 40 students who received a study score greater than 40 was in the top 2.5%. Okay, the tricky part is, well, how do you work out, for some students, how do you work out 2.5% of 14,500? Okay, and the easiest way to do that is to go 2.5%, or 2.5 I should say, divided by 100, and then times it by the number of students, so 14,500, and that will give you an answer of 362.5 students, which when you round it up is equal to 363 students. Okay, so that's the calculation. You wouldn't need to necessarily do all those steps, but that's the logic behind how you work it out. So the last thing I'd like you to have a look at is the last slide. Is from all that information that we've done, can you now work out a past exam question based on the same information? So again, pause this, give yourself 2 minutes to answer the question, and then when you stop pausing it, I'll go through the answer with you. Or you can check your answer by me explaining it. Okay, so hopefully you've had a go at doing the question. Same thing again, we're looking at normal distribution. So what I would be strongly suggesting that you do is that you've drawn, and I need to get better skills at drawing on the computer, but you need to have drawn in the normal distribution. Okay, we have a mean of 8.8 and a standard deviation of 2.2. So I know straight away, and I'm just going to change it so you can see it nice and easy, is that 8.8 is in the center here. Okay, and if I subtract 2.2 from it, it gives me 6.6. And if I add 2.2, it gives me 11.0. Now, I'm actually only interested in the 6.6, but I've done both just so you can see the calculation. Now, obviously, if 6.6 wasn't your answer, you'd then have to go out 2 standard deviations and 3 standard deviations, but that's to give you an idea. I'm after this value here. This is 1 standard deviation. So again, you should be saying, I know that 68% is within 6.6 to 11. And I also know that what's left over is 16% is below that and 16% is above it. Not that my graph shows that very accurately, but it is. Okay, so it's just a quick sketch to see what's going on. So, what does the question ask me to do? What percentage of the car, what percentage of this model of car has a fuel consumption less than 6.6? Okay, and then you know the answer straight away is C, 16%. Okay, hope that was useful. If you've got any questions, remember to ask in class tomorrow. See you later.